Today we'll discuss about maximum power transfer theorem for DC network. This theorem states that the maximum power will be delivered to the load from the source when the load resistance is equal to source resistance. So here in the circuit you can see this is a proof for this. Okay, this is a circuit, it's a DC network. We have one DC source V and internal resistance RS, and this is the load. So load you can consider it as a variable load where you can you have to find out for what value of RL maximum power will be delivered to the load. So here what the theorem states that maximum power will be transferred to the load when this RL is equal to RS. Okay, we have to prove mathematically also how it is correct. Okay, so first I am going to write an expression for current I in the circuit. So normally you take any problem related to Norton's theorem or Thevenin's theorem. Okay, so any problem we know that any complex network can be converted into simple voltage source in series resistance, that is Thevenin's theorem. So better for all the problems related to maximum power transfer theorem, first convert given complex network into Thevenin's equivalent circuit where you have VTH in series with RTH. So here we considering voltage source now. V voltage source internal resistance is RS. Otherwise, you can also consider this as a VTH, okay, because it is a voltage source, and RTH by assuming that the given network is Thevenin's equivalent circuit. So for all the problems, whatever problem they will ask in the exam, try to convert that one into voltage source in series with resistance by using Thevenin's concept. After that, we can consider RL, and we can tell that the for maximum power transfer theorem RL is equal to RS, and this is for DC network. Okay, now we have to write expression for I here. We have to write expression for I here. So this is the current. Okay, current I is given by, okay, you can write here, this is the current I. So I is given by voltage divided by RS plus RL, and power is given by V into I. Okay, V into I, again V is equal to I into R, so that we will going to get I into R into I. So power is in terms of current is equal to I square into RL. Power is equal to I square into RL, and substitute the value of I here. Substitute the value of I here. I is equal to what? In this simple circuit, voltage divided by RS plus RL is the I. So this is I actually. Okay, this is I, current I, and substitute the value of I, V square by RS plus RL whole square. This is the I square value into RL. So this is expression 1, and it is power delivered to the load. Okay, now using mathematics we can find out the maximum and minimum of any function. We have to differentiate and you have to equate it equals 0. So differentiate this P as a function of RL. So dP with differentiate with respect to RL. dP by drL is equal to 0. So we know that differentiation of fraction, that is P by Q. For example, this is numerator and denominator. If you give some ratio, then denominator square, RS plus RL square whole square. So it becomes RS plus RL whole to power 4. So denominator square into, okay, then denominator into differentiation of numerator minus numerator and differentiation of denominator. That is the formula for differentiation of a ratio, P by Q or something. Okay, so here it is in the form of numerator and denominator. It's a ratio P by Q. So now I am going to differentiate with respect to RL. So V is constant, RS is also constant. Okay, voltage, source voltage is constant, its internal resistance is constant. Only variable is here, the variable is here, RL is variable. You have to find out for what value of RL. Okay, RL is variable, so I am differentiating with respect to RL. So denominator square, RS plus RL square whole square is equal to 4, and we have to write denominator RS plus RL whole square. Okay, and differentiation of numerator, V squared is constant, so keep as it is. Differentiation of RL with respect to RL is 1, so here you are going to get 1. Next, minus numerator V square into RL, denominator differentiation. So actually denominator we have RS plus RL whole square. Differentiation of this square is equal to 2 times RS plus RL, 2 times RS plus RL. Again differentiation of RS with respect to RL is 0 because RS is constant. Within a bracket you have to write 0 plus 1. Differentiation of RL with respect to RL is 1. So you are going to get 0 plus 1, and this multiplied by 0 is 0, and this multiplied by 1 is only this much you are going to left. So actually you are going to get 0. Differentiation of RS with respect to RL is 0, plus differentiation of RL with respect to RL is, that is 1. So 0 plus 1, it is nothing but 1. So you are going to get 1 here. Now this you have to equate to 0. This you have to equate to 0. Now this is differentiation of u by v with respect to x. Okay, denominator square. Okay, this is not required. No need to write this one. You no need to write this one. Just I wrote by applying that one only. So denominator square, denominator into numerator, differentiation of numerator minus numerator differentiation of denominator. This you have to write d by dx of u by v. D by dx of u by v. It's not. It should be dx. It is u by v. Okay, d by dx of u by v is this v square v into du by dx minus u into dv by dx. This is a mathematical formula. Okay, for any function to be maximum, this dp by drl should be 0. This and in this part denominator cannot be 0, so only numerator should be 0. So take numerator and equate to 0. So v square rs plus rl whole square v square rl, this part should be 0. So v square is a constant. Divide throughout v square left side, and you bring this one to right side. Numerator should be equal to 0. Numerator should be equal to 0. You bring this term to right side. After that v square both side you can divide throughout, and rs plus rl. Here if you throw divide by rs plus rl, it is rs plus rl, only one term is there, this will cancel. This is whole square. Whole square means 2 times will be there. So if you divide throughout by one another one term will be there here. Okay. So if you equate, you'll get 2RL is equal to RS plus RL. So bring this RL to left side. So 2RL minus RL is equal to RL. RL is equal to RS. So this is proved. Hence we proved for maximum dp by drl is equal to 0. So we derived RL is equal to RS. This indicates that maximum power will be delivered to the load from the source when RL is equal to RS. That is nothing but load resistance is equal to source resistance. This is in the case of DC network. And what is the maximum value of that power? So it is I square into RL, and we have to substitute RL is equal to RS or RS is equal to RL. So wherever RL is there, we have to substitute by RS. So V square by RS plus RL is also replaced by RS into RS. So 4 V square by 4 RS. This RS plus RS is 2RS. 2RS whole square is 4RS square, 4RS squared, and numerator RS will cancel one square value. So we left with this. This is 4RS squared. You're going to get 4RS squared into RS. This RS we can cancel with square value. So finally we left with V squared by 4RS or V squared by 4RL, because RL is same as RS. So you can write either RS or RL. So normally in the problems, maximum power transfer theorem, any problem given, it is replaced by Thevenin's equivalent circuit. So VTH and RTH. So we can also write that RL should be equal to RTH. Okay, source resistance should be equal to RTH. Indirectly it is nothing but source resistance. So that you can also write here power is equal to VTH square by 4 RTH. And we also we have to consider as Thevenin equivalent voltage VTH, and this is RTH. So in general it is given as V and RS, where V is voltage source in series with internal resistance. But if they give some different circuit, we have to convert that one to Thevenin equivalent circuit, where we are writing VTH and RTH. So wherever V is there, we can write VTH. This is RS. Instead of RS, we can write RTH. And here we can write power maximum is equal to VTH square by 4 RTH. Okay, we can also write P is equal to VTH square by 4 RTH. So this is very, very important question. Remember, maximum power transfer theorem, there are three statements. Maximum power transfer will be delivered to the load if it is a given network is a DC network when RL is equal to RL. RL is equal to RTH. That is nothing but internal resistance of this voltage source. Okay, so we have other two statements for maximum power transfer theorem, other two cases. I refer that in my next video.